Morning, guys. Watch this lesson. Here's something for you to see about cross sections, and let's see if we can just hammer this out. I know they're a little tricky to get, but just okay. Watch kind of this tutorial as I'll do it for you. All right. So what I'm going to do is so here we go. I'm going to basically one second. Basically, I'm going to start with there's my x, and then now here's my y. All right, and now all I'm gonna do is, this is just pure coincidence that I'm picking this one. I just wanna show you a curve. I'm gonna basically say y is e to x, okay? So thus I have this graph, and here's what I wanna do, is I wanna just investigate it from 0 to, let's say, 5. I always pick 5 because 5 is my number in ice hockey, actually. So that's why, if you're always wondering, why do I do 5? It's my favorite number. It's the number on my jersey. Maybe next time I'll even record with my jersey for you, so you can see the number. Okay. All right. So watch what we're going to do with this now. This is basically just so you really kind of get it. Then watch this. I'm going to add in basically that. Let's see if I can get it to go straight. And there would be basically y equals 0. Okay, and thus I'm capturing this. I'm going from e to x to 0, and my bounds are 0 to 5. Nothing new here. I'm saying let's go from 0 to 5 of e to x dx, and that's represented right there. Okay, watch what I'm going to do now, though. So here we go. I'm now going to draw. There's going to be my x. Actually, you know what? Watch. I got a better idea on how to do this. This will be my x. I'm just going to draw just the x and now just the y, just to give us a focus point. All right. Then here's my e to x. And I'm going to go like that. And then I'm going to mark 0. I'm going to mark 5. Here's what we're doing. All right. We're basically still talking about the x-axis, right? So what I'm going to do is cut a perpendicular cross section of this. So what that means is, of this section right here, I'm going to cut, like literally make a cut of just a section, right? And I've done this a couple times. I'm just trying it one more time to just kind of help you with it. There's my cut, right? And from that cut, I'm going to make a shape out of this cut. This is the start of some shape, okay? Now, so you can get this idea, here's the idea that I had with this technology. Watch this. So what we're going to do is I'm going to take this and I'm going to spin this like this. And what you are going to see me do is build a shape out of that now that's kind of coming up at us. The shape I'm going to build is, I'm just going to build, what if I do a semicircle? So that would look like that, right? And it would be a shape pretty much like that. So then there would be my next cut, and then my shape would be like that. So I have all these semicircles basically coming out of this, all right? And then there would be my semicircle too, just so you get it. It's just this, I just want you to understand in the picture this. It's so important. You can see that. It's just, oh, sorry, I think I went off the page there. Oh yeah, it's not gonna like that, it's all right. It's basically a semicircle going from that to that, right? It's all these semicircles added together. So I'm going to call this big one A1. I'm going to call this guy A2. And then this guy would be A3. And then this guy would be A4. Where I get the volume out of this is, this would be like my thickness, which would be my delta X. Okay? That's where the volume starts to come out of that. Thus, really what I'm doing is I'm taking A1 plus A2 plus all of these guys, adding them together. And then I'm just adding up all the areas. Now, that's just the idea of if this was like a semicircle. So again, the shape that I'm making is just semicircle after semicircle. So I'll try to draw one like right here. So it would go like this. It would go like this. And basically, there's my semicircle. If you can picture it coming up and out like that. And it's just all these different semicircles, okay? Thus, all I'm going to do is this, everybody. I'm just going to take the sum of them all. Right? And now all of a sudden, if I get these semicircles infinitely thin, I take the limit as basically delta x or n. We can go any which way with this, but not just to confuse you too much. I'm going to take the limit as basically n goes to infinity to keep all of our terminology the same. And you see this, I hope, come to life. You have these infinitely thin semicircles, and we're just adding them all together. All right. So let's just do the math. Let's see what happens here with the geometry. All right. Circle. Area of a circle is pi r squared. Gotcha. Okay. Interesting fact, though. That's a circle. I have a semicircle. So what I'm doing now is I'm basically taking a half of this. So I'm taking half of all of that because it's a semicircle, not the entire circle itself. So the area of this thing would be 1/2 times pi times r squared, because that's the idea of using just that as a circle. Now, here's the other connection. I think some of you are maybe can see this already where I'm going to allude to this. See this r? That's not r, though. That's my issue that I'm at right there, is with that connection right there. The color just brings it to life. I love using these little colors. Radius would be pretty much just that. So now let's just talk about this. That would be my r. So this would, let's look at A2 right here, basically. So then there's my point. This thing to this thing would be my r. Now, this is the neat concept. That's what E of x is, right? If I rotate this back, so if we flip this back to what it was, you can basically see, oh, that height is exactly what that is. So the diameter is basically just all the outputs coming from E to x, right? So now I have a manipulation where I can see the area of these things is 1/2 times pi, but the radius now is actually half of whatever E to x is, quantity squared, because that's what's replacing the r, right? Therefore, the area of one of these semicircles would be 1/2, there's the semicircle, times pi times 1/4 e to the, oh, good. Great review here. What happens when you have a power raised to a power? What do you do when you have that? You multiply. So that would be e to basically 2x. If I clean that all up, class, that's going to be the area of this thing is pi over 8 e to the 2x. That would be one of them. Now, just sum them all together, make them infinitely thin, and all of a sudden, I can go like this. I've got the integral from 0 to 5, pi over 8 of e raised to 2x dx. Okay? Neat part is, to try to show you this is the depth. So there's a dimension, right? And then there's a dimension. And there's 3 dimensions coming from this now. So you can see this, how all of a sudden it becomes volume. Now if we just use math to solve it out, this is the part I always want you to practice. 0 to 5 of e to 2x dx. What that would do is basically, now, if I unzoom this to show you the whole picture, right? The whole concept is that this calculation now, this whole calculation I got here, is if I added up all these different semicircles from basically 0 to 5. So the neat idea is I want you to see one screen, the connection of basically how this works. And therefore, I've seen a very, very common pattern, which I'm going to get to you again to. I'm keep trying to let you lead to the pattern to see if you can discover it. But basically, if you got a semicircle, you can always just think it through like this. And so I can give you any function, really. I can set you up with any axis. And let's just think about it, right? I can just do something as simple as, let's do basically y equals, let's go 5 minus x. So that would be a line that runs exactly like that, right? And basically then you have the idea that this is basically my area that I'm just basically looking at. There's my slab, right? And now what I'm going to do with this idea is I'm going to rotate this like this. And what I'm doing is now cutting just one little piece, and I'm making a shape out of that piece right there. Our previous video said, hey, look, we can make a square. So that'd be a square right there, right? Then this guy, I could make another square right there. Then I can make another square right there. And I have all these, oh shoot, that wasn't a good one. There we go, a little bit better, okay? I've got all those squares, and the interesting part is the squares are being built off this idea of what is basically this height right there. What is that? What is that? And that's how we build this with all these shapes, okay? It just, I think, I was just thinking about it. When you flip the axis, I think you see it a little bit better. So this is just a small little video. I hope to help you with perpendicular cross sections. You have a whole sheet now. I have this ready for you of all the different cross sections in each one, okay? So basically, if I look at, this is right from basically Kevin and I's idea of how to show this to you. If you basically have these two functions, and you're bounded by these two functions, you have this idea right here, okay? And then you can just kind of see me walk through the whole thing. So I'm building this slab, this red thing, right? And now I want you to see I have all these shapes ready to show you. I have squares, I've got rectangles. Rectangles where something's 5 times the base. I have a quarter circle, I've got a semicircle, which we just did, and I have an isosceles right triangle, okay? And then I got an equilateral triangle. And basically now I can show you a pattern that's really neat. And this is the pattern that I've kept alluding to. Every single pattern has this happening, right? There's this slab. There's the slab squared. There's the slab squared. There's the slab squared. There's the slab squared. And you can see this pattern. It just keeps existing, squared and squared. And thus what I'm going to do is show you a nice, beautiful idea of, guess what? This now will be, if you have a cross section with these different shapes, here's an ultimate guide to show you through these cross sections, okay? Each one just has a very neat manipulation, and I'm going to just have a nice little list remembered. Oh, yep, that's how that one works, okay? So the shapes that we're after that I want you to understand is we have a square, we have an equilateral triangle, you've got an isosceles right triangle, you've got a semicircle, you've got an isosceles right, a quarter circle, and a rectangle. Of course, you could make some weird shape, but these are the shapes on the AP exam. These are the ones that basically I know that you're going to see. So basically, here's a guide to help you through the homework now about what happens if you have to go through a shape like this and you have to cut it. I love doing these problems because the geometry comes out to light. Just the idea of, I could basically look at any function, and then basically there's my y, and then there's my x, and I can now just look at it in terms of basically, what if I just cut a slice from it? So here's my basically, I'll just make this like a polynomial. We'll go like that, and then I'll do something like, let's go something like that. Right? And you're wondering, what am I alluding to? What I'm trying to allude to you is this abstractly, this little section right here. And now what I'm going to do with that section is basically look at it in like this. There's a slab right there, right? There's a slab right there. There's a slab right there. There's a slab right there. This one is very interesting because the top and bottom change. So for instance, I hope I've taught this the right way. This is the top part right here, and then this is the bottom part right here. And so I'm traveling and top to bottom, but then all of a sudden it's going to switch. This is now the top. I'm going to call it T sub A, going to the same bottom. But if you look at our curves interacting, this curve was the top, then it stopped. Right there was the last time that top bottom slab was made, from this to this. Now this curve all of a sudden took over there, and so you now have a much different calculation that I would have to show you through. I could walk you through it, but it would be basically T minus B for this section right here. That would be that top minus bottom. And then for this top minus bottom, it's going to be a whole new calculation. It's going to be this guy, and it's going to be T sub A minus B. And now you have the idea that we're going to test you, and we're going to see if you can understand this. And now I've involved two things. I've involved the top bottom, but still, don't forget, this is going to be the neat part. I hope you can watch me do this now. I'm going to take this thing and I'm going to rotate it, right? And just, it's still the same idea, but what I'm doing with that is making a shape. So for instance, if you wanted to think about what this would look like, it'd go like this, and that would be like my semicircle right there. Then this guy would be the semicircle right there. Then this guy would be that semicircle right there. And that's if I was doing semicircles, right? Neat part, I can do this now is show you I can just take this all away. What if I just change the shape? And that's what our learning, that's like our last lesson. What if I made this an equilateral triangle like that? Then this guy would be this equilateral triangle like that, okay? Then this guy would be that equilateral triangle like that. So it's the idea that you're cutting these cross sections out, and it's the last thing. Why you would do this is architecture. This is a really, really neat idea about architecture on how you could cut a slab and you could make a building come to life. I challenge you to think about that. What type of, if you can look at a building out in our world, look and see if you could understand somehow they've been constructed by perpendicular cross sections. Think about all these unique shapes that we have in our world. It'd be fun to just kind of look at it because, I mean, if you have some time, it wouldn't hurt. So, but there we go. Okay. Again, this is the key sheet, and basically, I'm gonna send you it as a PDF as a nice summary. But I just want to give you a video walkthrough, guys. I hope you're having a great Thursday. Sure do miss you. Have a wonderful weekend. Enjoy some downtime. It's pretty cloudy outside, I can see. So I wonder if we got some rain coming. Hope your first couple of days have been good, and you sure are missed, kids. Have a great one. I will see you next week.